Hi, my name's Graham Helfrich. So I have toast every morning, and imagine if I show up to my kitchen, I see this monster of a toaster there. It's got a lot of buttons and options, and I burn my toast. I can't figure out how to use it, then I have to put it through multiple times, and I just get really frustrated. Now, this is a problem because I have toast every single day, so I need it to be easy to use. Well, the same is true for production engineers when it comes to IPR and tubing performance curves. It's something that they do every single day, so it has to be super easy. So today I want to show you using Whitson software how you can create an IPR curve and tubing curve without doing any RTA work, without doing any reservoir engineering, and just getting those results quickly. Let's check it out. So under wells, we're going to go ahead and add a well, call it whatever you want. And we're going to go straight down to nodal analysis. Here we're going to create our oil IPR curve. So we'll put in the current operating rate, GOR, bottom hole flowing pressure, water oil ratio, reservoir pressure, and bubble point pressure. And from that, we get our IPR curve, right? This is our average reservoir pressure, kind of our test point, and then this horizontal line is our bubble point pressure. Awesome. We did it without doing any RTA work at all. Let's do some tubing performance curves here. So for that, we need to know a little bit about the tubing depth and the diameter and stuff like that. So we've done that for you by default, and we just let you modify the values so you can get some results quickly. So under bottom hole pressure and then edit, we see that we've got a horizontal well, so 7,000 feet TVD and 5,000 foot lateral. You can go ahead and modify it if you want. Back down under nodal analysis, we're going to go edit well configuration, and we can see that we've got 2 7/8 inch tubing in here by default, and we're just going to flow naturally, no artificial lift at first, just to see what happens. So I'm going to put my tubing head pressure in as 1,500 pounds, click on create VLP, try it again here, and we see this is our outflow curve. This is our expected operating point. Great. I'm going to save this case as 1,500 psi tubing head pressure, no gas lift. All right. And now let's see, what if we drop that wellhead pressure down to 500 psi? Create that VLP. Well, now we can compare 1,500 pounds wellhead pressure versus 500 pounds wellhead pressure. Great. We're going to save that new case, 500 pounds. Now let's consider some gas lift. So I'm going to put the wellhead pressure back up high and go edit. And now we're going to change the artificial lift method to gas lift. Now I'm going to keep it as poor boy for now, just to keep it simple. And there's a save button hiding over here. So once we're on gas lift, we can put in a gas lift rate. Create VLP. Get my face out of here a little bit. And we can see that we have our no gas lift operating point and with a little bit of gas lift. This is what we'll get. So we'll save that as a gas lift case here. Save. And now what if we increase the gas lift rate to 700,000 cubic feet per day? Okay, we can start to see these kind of, no gas lift, a little bit of gas lift, more gas lift, right? We'll save this case, just keep track of everything. Now, if we want to get a bit more rigorous in our gas lift, we would go ahead and not use pour by, but we would pick this valve option. And that is going to let us put in all of our joints and different open close pressure for our gas lift valves, just to be a bit more detailed in terms of either planning coming off of natural flow into gas lift or just optimizing some existing gas lift that we might have on the well. Okay. Now, what about an ESP? What if we want to consider putting in an ESP on this well? So we are going to specify our depth of our pump. I'm going to put it at 6,500 feet because we have a total TVD of 7,000 feet for this well. Click save, and this is going to let us input our pump intake pressure. I'll put 1,000 pounds, create VLP, and this is our new outflow curve and our expected operating point. So we see that the bottom pressure is 1,070 psi. So that extra 70 psi, it comes from the difference between our pump intake depth, our pump depth, and the perforations. So we're considering the hydraulics under the ESP to come up with the correct operating point and the correct pressure downhole. So the whole point of this is, I make toast every day. It needs to be quick and easy. And production engineers do this sort of work every single day. So without doing any RTA or reservoir analysis, I wanted to just highlight how you can quickly get these results for an oil well and do these sensitivities super easy. Thanks for checking it out.